In this video, I'll help you solve the ALEKS problem called predicting the products of a single displacement reaction involving hydrogen. To help you with this problem, you're probably going to want to have access to a periodic table and also a table of common polyatomic ions. So this problem, all of the equations have the same general format. It's going to be a metal atom reacting with some sort of molecule. That molecule, the first atom in the formula, is going to be a hydrogen atom. I want you to just kind of notice that this particular structure is not the only type of single displacement reaction that occurs. It's just the one that ALEKS is using for this problem. So I'm going to give you really specific instructions for this type of single displacement, but the information that I give you does not apply to all single displacement reactions. The first thing that I want you to do is take a look at that metal atom at the beginning of the reaction. For this particular type of single displacement, that metal atom must be from either column 1A or 2A on the periodic table. If this metal atom is located anywhere else on the periodic table, the reaction will not work, and you're going to check the no reaction box. So for example, I saw some variations of this problem where ALEKS was using aluminum, which is not in columns 1A or 2A, and therefore the answer is no reaction. Second thing that I want you to do is take a look at the molecule that is reacting with your metal. And as I said, the first atom in that molecular formula is going to be a hydrogen. For some of the problems, the molecule that you're reacting with is water. And if you have water as your reactant, I want you to not think about it as H2O. I want you to think about that water molecule as HOH. It is the same thing, obviously, but it's going to make it easier for you to predict the products if you think about water in this format rather than H2O. In a single displacement reaction in general, the atomic reactant, in this case the magnesium, the thing that's in the atomic state, is going to swap with the cation or the first atom of the molecular formula. So what we're doing here in this reaction, or what the molecules are doing here, is just swapping, in my case, the magnesium for the hydrogen. Now, it is not as simple as just swapping those atoms straight across. Unfortunately, that is not how this problem works. Occasionally it works out this way, that this would be the correct answer, but when it does, it's just a coincidence, and it's never going to work out this way for this particular ALEKS problem. So in this type of reaction, we're not just simply swapping the atomic element for that hydrogen atom. We are actually changing the magnesium, which is in the atomic state right now, so it is currently an atom, it is going to turn into a cation. And the hydrogen, which is currently a cation, it is going to turn into, I want to say, its elemental state or its atomic state. For hydrogen, the elemental state or the atomic state is H2. And for all of these reactions, the first atom in this formula is always going to be a hydrogen. So for all of these reactions, when this displacement occurs, one of the products of this reaction is going to be the H2, coming from the hydrogen atom being converted from a cation into its elemental state. That H2 is a gas, and it is important for you to have the states correct for this problem. The magnesium is being converted from an atom into a cation, so we're going to go back to the periodic table again and use the periodic table to help us predict the charge on our ion. Now remember, all of these metals are going to be from either column 1A or column 2A on the periodic table. Anything that is in column 1A forms a +1 cation, and anything in 2A forms a +2 cation. So magnesium, because of its location on the periodic table, I know that my magnesium is going to be turning into the Mg2+ ion right there. So that is, I don't want to write it as one of the products yet, but that's what the magnesium is becoming. So the magnesium, I'm going to make a note down here. The magnesium is going to turn into the Mg2+ ion, and it is going to be bonding ionically with the chloride anion, or whatever your anion is in your molecule. So for me, I have this chloride ion. I need to figure out what the charge is on this anion in order for me to write the correct formula for the compound that's going to be created when this magnesium combines with the chloride. So I can predict the charge of a lot of anions, again, based on their location on the periodic table. These elements form -3 ions, these -2, and these ones -1s. Chloride, because of its location, I know is a -1 ion. There's its formula right there. So when this reaction occurs, when the magnesium is turned into the cation and then binds with that chloride ion, I know that I am going to need 2 of those chloride ions, Mg Cl2 to have a overall charge neutral product. I'm going to get this out of the way. Okay, so that other product, the second product of this reaction, is always going to be aqueous. Now, sometimes you are over here going to have a polyatomic ion, not an ion that you can find on the periodic table and predict its charge, and that's why a table of polyatomic ions is really handy, because a table of polyatomic ions is going to help us predict the charge of whatever that anion might be. Before I balance this equation, it isn't balanced, but before I balance it, let's do this same reaction. I'm just going to get this arrow out of the way. Let's do this same reaction pretending as if my other reactant was water instead of HCl. So you can see why the HOH notation is helpful. So if I was doing this reaction with HOH, again, I would be combining or swapping the magnesium for the hydrogen. The hydrogen, when it gets displaced, always turns into elemental H2, so that would give me H2 gas. The magnesium is turning from the atom into a cation, which I know is the 2+ ion because of the location of magnesium on the periodic table. This, my anion, is not a single element, so it's not on the periodic table. I can't use these to help me predict its charge. This is a polyatomic ion, and I need to go to a table of polyatomic ions to find its charge, OH-. So in this second version of the problem where I'm reacting it with water, my anion is hydroxide OH-. I'm still going to need 2 of these anions to balance out the +2 charge of the magnesium. I'm going to communicate that like this. And then for both of these, the last thing that you need to do is balance this equation. It's never going to be balanced. It's never going to work out as balanced. So number one, first of all, the hydrogen is always going to need to be balanced. You're always going to have too much hydrogen on the right-hand side of the equation. It looks like for this problem, that's all I need to do to balance it. For this one up here, looks like it's the same thing. Okay, good luck. This is actually a pretty tricky problem, so good luck.